All right. Hello, everybody. Mr. Pryor EDU, Mr. Pryor's education, however you want to look at it. I am here to start with college chemistry. This is November the 21st of 2024. Hopefully, these videos will be up to help all of you. And just to get started, all right, everybody. Hello, Mr. Pryor EDU. Glad to see you. I like to make things easy to understand, simple to understand, while having some fun with it, right? Let's have some fun with it. So, classification of matter. Well, let's first look at the picture. What do we see in the picture? Well, let's just pretend this is a microscopic view of a liquid. It could be a gas, but let's say it's a liquid, for example, and we're just looking at things and we're seeing, just looking at it like a toy. We see one, two, three different types of atoms. If these balls represent elements, then when two elements are connected, we've made some kind of compound. And a compound can be pure. It can only be one substance. But what do we notice here? We see three different compounds. This couldn't possibly be a pure. This couldn't possibly be pure. Okay, this is definitely a mixture. It's a mixture. It's not a pure substance at all. If we had just these purple and three green molecules, these purple and three green atoms, and if that was the only thing we had in the solution, and we got out the orange single atom and the di element here that's in blue, and we only had this, we'd have a pure substance, okay? But we don't. We have three different things in here, so we have a mixture. Now, that doesn't apply to what it looks like overall. It might look like it's all the same substance. We might not be able to just look at something and tell if it's a different substance, right? We can't always do that. Most of the time, we can't do that. We can't look at the air and see that the air isn't pure. We just know that. Okay, so like pure substances, mixtures can be solids, liquids, or gas. So mixtures too can become solid, liquids, or gas with respect to their physical states. Okay, so mixtures are homogeneous, having uniform composition. They may be, or they could be heterogeneous and have variable compositions, meaning that the solution looks different in different parts of it. Where in a homogeneous solution, it's like a glass of water, it all looks uniform. So if we were to take even, okay, say we have a pure glass of water, we dissolve some sugar in it. Uh, we can't see the sugar once it dissolves into the water. It still looks like it looks like it's completely the same. It's definitely not pure because we know we have water and sugar, not just water. So it's not a pure substance anymore. It now contains two different components, sugar and water. It is homogeneous to the eye. We cannot differentiate without a spectroscopy device, some kind of analytical device. We can't tell what it is. We just it looks all uniform. So it's a homogeneous mixture. Now take and mix. Take for example two solutions. Then maybe it's a solid, not a solid, but a granule. Okay, these are solid granules, but we could have a glass of sand and we could have a glass of iron fillings. Okay, so we would have a heterogeneous mixture just looking at the sand, and we'd have a heterogeneous mixture just looking at the iron fillings if they're grounded up small enough. It wouldn't look any different to our eye, but that would be, these taken apart would be homogeneous. But if we took the sand and we took the iron, we poured them into one container and mixed them up, we could see what looks like sand, which is like tan color, and we could see what looks like iron because it's black. So we would end up having a heterogeneous mixture where two substances remain distinct to our eye or discernible to our eye. Um, so some examples though of homogeneous mixtures before we get to heterogeneous. These are the easiest to understand. Coffee, you don't, unless you've added a bunch of cream or some kind of whipped cream, it's going to be a homogeneous mixture. Wine, it's purple in this case. Air, as I mentioned, brass color, It all looks like golden brown. Steel could have carbon and iron in it and other things, but it looks homogeneous. But it's a mixture because it has other compounds in it. It has multiple elements that may form various compounds within it. Natural gas. Yeah, that might have different, it might be methane and propane or whatever's in there, a mixture of different gases, but it still looks homogeneous. Vinegar, it has water and acid and different anions and cations maybe floating around in it. Blood has all sorts of things floating around in it. It's um, it's very much a mixture, but it looks like just pure red substance to us, so it looks homogeneous, right? So, um, and let's move on. Okay, heterogeneous mixtures. What do those look like? Okay. We've seen it in salad dressing. We know how that looks with salad dressing, right? Let me adjust. And then we have beans here, jelly beans, which is cool. Wasn't I think a president liked jelly beans. Here we have some candies. This is gonna make everybody hungry who's watching this. And if we break this open, it looks distinct in different ways. The inside is kind of light brown, the outside is dark brown. The outside is kind of uh, not kind of smooth, and then you look on the inside, it's kind of granular. So very heterogeneous, and it's a mixture, of course. All of these are mixtures, there's no question. And all of them are heterogeneous to our eyes. They look different at different parts. If I put my arrow here or I put my arrow here, uh, it looks a little bit different, right? So here you got cheese and you got lettuce and tomato. All this stuff is a mixture. A salad is a heterogeneous mixture. A Napoleon ice cream, we got chocolate, vanilla, and strawberry, and then we got strawberry fruits here. It's a complete mixture of different things, right? We also know there's other food products in here, so this is cool. So you can use this stuff to help you think about your world. Now, how do we identify matter? Well, we start with first what we've learned in our previous videos. We know matter is almost everything. And is it matter a substance or is it a mixture? Okay. If it's a mixture, we can separate it by physical means. We can filter, maybe we can distill it, maybe we can use centrifugation, some type of filter, right? And then we can get pure substances, right? If it's a substance and we're talking about a pure substance, we're talking about something that's pure, so it's not a mixture. So we don't, once we are able to separate things into individual components, separate sugar from water, we're dealing with it's just going to be a pure substance, and of course it's, if you separate it correctly, it's going to be homogeneous no matter what, and it's not a mixture. You've separated it into a pure substance. So pure substances could be a compound, pure substance could be an element. A compound, for example, H2O, an element, O2. Just getting to separate oxygen by itself is quite a challenge. It's a chemical challenge to store pure oxygen. It takes money to do that. It takes resources to do that. Now we separate these by chemical means, and that's different than separating by physical means. So we can't break a compound into its elements without breaking bonds. And if we break bonds, we're talking about chemistry. We're not talking about physical separation such as ice to water to gas, which it's still H2O. But back here, we just learned these two. We got a mixture. We have really two things to decide on. Is it a homogeneous mixture, meaning it looks just completely the same throughout, or is it heterogeneous and looks different throughout, like the salad? So this has been mrpryor.edu. Subscribe, like the video, share it with your friends. Peace out.